Trying to get a message from one host on a network to another host, like from the laptop to the server here, there are a number of things that could go wrong. Maybe the server disappears, or maybe some part of the network that reaches from the laptop to the server disappears. Those are problems that we can't do much about, and we're not really going to try to address those today. But the thing that most often goes wrong is that the message in packet form that's being sent from the laptop to the server just gets dropped. The routers get overloaded or something temporarily goes wrong with routing so that the packet never gets there. So we're going to focus on packet delivery problems today and think about how we can make sure that when we have a packet and we try to send it, that it actually gets there. We will not be able to make a perfect solution even to just this problem. Then again, we don't have to because, after all, even worse things can always go wrong. But we do need a solution that makes packets delivered correctly most of the time. So part of the solution, of course, is going to be resending packets that don't make it. But the trick is knowing when the packet didn't make it and at what point you should try resending a packet. We could solve this problem at different layers of our network stack. We could solve it at the application level, for example, by requiring applications to know something about whether a packet got there and have their own mechanisms for retrying. And for some applications, that's appropriate. But we're going to look today at implementing this at the transport layer, which is, of course, the layer where TCP provides reliable data transfer. So we're working our way towards TCP today. That is, at the transport layer, it needs to export to the application a reliable data transfer model. So an application, when it sends data over this, sends it to the transport layer, it expects that it's going to get there eventually. But the transport layer itself is going to be built on potentially unreliable layers. So maybe the network sometimes drops IP packets, or sometimes the Ethernet cable or the Wi-Fi that we're talking across has some problem or interference. We can deal with those kinds of problems here at the transport layer so that applications don't have to deal with it. And again, the kind of things we're talking about are lost packets, packets that just get dropped along the way, or it's not just lost. Another thing that can go wrong is all the packets you sent actually get to the other side, but they get there in a different order. And the reliable data transfer layer's job is to make sure that that's okay, that either it sorts them into the right order or it throws away the ones that came too early or too late and tries again. Another thing that can go wrong is that packets can get duplicated at these lower network layers. So not only does the packet get there, but maybe it took a couple of different routes and they both succeeded, and we only want to pay attention to one of them, not both of them, because the application assumed that the message would just get there once. And finally, it's possible for the packet to get there, except it's not actually the packet we sent. The data might be corrupted through the other layers of the network. There are all sorts of mechanisms in these lower layers to try to prevent corruption, but they can't prevent everything entirely, and we want our transport layer to do the best job possible in making sure that data is not corrupted along the way.